Welcome and study with Tanzania Institute of Education.
Hello, welcome to our chemistry class. My name is Madam Jennifer Kazilege. I'll be with you discussing our topic known as hydrogen. Hydrogen is the lightest and most abundant element in the universe. Therefore, we can prepare hydrogen in the laboratory with different methods. Now, let us see how we can prepare hydrogen in the laboratory. Preparation of hydrogen in the laboratory. Preparation of hydrogen in the laboratory. As I told you that hydrogen can be prepared by various methods. Number one, hydrogen can be prepared by reaction of dilute acid with metal. That is number one, whereby we can prepare hydrogen in the laboratory. But number two, we can also prepare hydrogen in the laboratory by reaction of water with the metal. So also we can prepare hydrogen, or we can obtain hydrogen in the laboratory when water will react with metal. But number three, it is the reaction of water with the hot carbon. Also, this is the method we can also use to prepare hydrogen in the laboratory. And lastly, the method is known as electrolysis of water. Electrolysis of water. So these are the methods that we use to prepare hydrogen in the laboratory. But out of four, the common method used to prepare hydrogen in the laboratory. The common method used to prepare hydrogen in the laboratory is method number one, which is the reaction of dilute acid with metal. The reaction of dilute acid with the metal. Now let us see what happened when metal will react with the dilute acid. What will happen when metal will react with the dilute acid? As the common method for preparation of hydrogen in the laboratory. So the common method for preparation of hydrogen in the laboratory, is the reaction of metal with dilute acid. Reaction of metal with the dilute acid. And what are those acids we are using to prepare hydrogen in the laboratory? The answer is the acid used, which is used, it is either sulfuric acid, it is either dilute sulfuric acid or dilute hydrochloric acid. So we are either using dilute sulfuric acid or dilute hydrochloric acid. Any of the two, one can be used to prepare hydrogen in the laboratory. But also, before we go to see the reaction taking place, we need to know what are those metals which are used to prepare hydrogen in the laboratory. We can use the most reactive metals. Or we can use the moderate reactive metals. But most reactive metals are not recommended to prepare hydrogen in the laboratory. The question is why we are not using the most reactive metals like potassium and sodium in the laboratory. The answer is because the reaction will take place while it is very, very eruptive. The reaction is very eruptive. Therefore, we cannot use potassium or sodium to prepare hydrogen in the laboratory because the reaction is very vigorous, and if the reaction is very vigorous, that means it may cause even fire accident in the laboratory. So the recommended metals that you are using to prepare hydrogen, it is either zinc metal or magnesium metal. So we are preparing hydrogen from either reaction of dilute acid with zinc as the moderate reactive metals or magnesium. So we are going to prepare hydrogen today from zinc granules, which is zinc metal, and the dilute hydrochloric acid. So we are preparing hydrogen in the lab. We are using the moderate reactive metals. As I've told you, we cannot use potassium and sodium. Why? Because potassium and sodium are most reactive. They are the most reactive metals, and since they are the most reactive metals, the reaction occurs very, very vigorously. And since the reaction occurs very vigorously, it is not recommended to be used in the laboratory. Therefore, we are preparing hydrogen by using moderate reactive metals with the dilute acid. So now let's see what are the chemicals. Chemicals, we must have dilute hydrochloric acid, hydrochloric acid. How do we write the formula? The formula is HCl. This is dilute hydrochloric acid. And another thing that you're going to use, it is zinc granules. And what the formula for zinc granules? The formula is Zn as a symbol for zinc. Now, we need to see the setup. Of the preparation of hydrogen in the laboratory. And later on, we are going to see the chemical reaction which will be taking place in the preparation of hydrogen. Before we see the setup, what are the apparatus used? What is the apparatus used? We must have a flat-bottomed flask. Also, we must have a delivery tube. Also, we must have a retort stand, or you cannot use a little stand, not necessary, but also we must have what you call a trough. Not only trough, but we must have a beehive shelf. And also we must have a thirst funnel. So the last one, we must have a gas jar. So these are the apparatus that you are going to use when preparing hydrogen in the laboratory. And what is the setup for this apparatus? So this is the setup of our reaction. Make sure you draw a good and neat diagram. This is a flat-bottomed flask. Inside the flat-bottomed flask, you are going to place the thirst funnel, and it will be allowing the acid to pass through and going to meet zinc granules. Inside the flat bottom, the flask, you're going to add zinc granules. And also we must have the delivery tube. We must have a delivery tube to transfer the gas to the gas jar. We must have a delivery tube which will be transferring the gas into the gas jar. Make sure you follow me and try to draw the diagram as I'm doing. We must have a trough, and this is the beehive shelf. Fill the trough with water, fill the trough with water, fill the trough with water. We are going to see what the function of water into our preparation of hydrogen. Then over the beehive shelf, you must place a gas jar. Over the beehive shelf, place a gas jar, which is going to be collecting the gas. And therefore, this is our gas jar, and this is hydrogen gas, while this is called the gas jar. This is called the trough. Inside the trough we have water. Then what it is, a beehive shelf. Then what it is, we call it a delivery tube. Then inside the thirst funnel, we had, what do we put? We put dilute hydrochloric acid. Hydrochloric acid. And in the flat bottom the flask, there are zinc granules. And this is a flat bottom the flask. So this is how you are supposed to set your diagram. This is how you are supposed to set your diagram. So inside the flat bottom the flask, the reaction will be taking place when dilute hydrochloric acid will be added. It will meet zinc in the flat bottom the flask, and the reaction will occur. And after the reaction occurring, the gas will be transferred. The gas will be transferred to the gas jar. The gas will be transferred to the gas jar. So make sure you know how to draw this diagram, because you may be supposed to explain the laboratory preparation of hydrogen using a diagram. You may be supposed to explain the laboratory preparation of hydrogen using the diagram. Then after we have seen the setup of the diagram, let us see what is happening within the reaction. What is happening when zinc will meet dilute hydrochloric acid? What is happening in terms of chemical reaction? What is happening in terms of chemical reaction? Now, we call it the reaction taking place. We call it the reaction taking place. Reaction taking place. So, it is dilute hydrochloric acid, hydrochloric acid. This one will react with zinc granules. Zinc granules, my space is not as big as enough to light it in a wrong way. This one will produce this halo indicative yield or form. When hydrochloric acid will react with zinc granules, what will happen? It will form zinc chloride plus hydrogen gas. 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 This is what is happening. This is what is happening. And the question is, what is this kind of reaction is named in chemistry? This is called the Wade equation. This is called the Wade equation. So when you'll be required to write a Wade equation for preparation of hydrogen gas in the laboratory, this is the Wade equation. Hydrochloric acid react with, we say that react with zinc granules. When they react with zinc granules, what will be the product? The product will be zinc chloride plus hydrogen gas. The product will be zinc chloride plus hydrogen gas. And then this is the Wade equation. How can you write the formula equation from this Wade equation? We write the formula equation. Formula equation. What is hydrochloric acid? We know the formula for hydrochloric acid. It is HCl. HCl. Then this one will react with zinc granules. Zinc granule is Zn. Zn. And what will be the product? The product will be zinc chloride plus. What is the other product? It is hydrogen gas. Zinc chloride plus hydrogen gas. So this is the formula. This is the formula for preparation of hydrogen gas in the laboratory. The formula for preparation of hydrogen gas in the laboratory. So now I guess we have understood what is the reaction taking place within the flat-bottomed flask. This is the reaction taking place. Hydrochloric acid reacting with zinc, producing zinc chloride and hydrogen gas. Zinc chloride and the hydrogen gas. So if you are required to write the chemical formula, this is the chemical formula showing the reaction taking place in the laboratory. So this is the chemical formula. Now we have seen the setup of the diagram. We have seen the reaction taking place, the Wade equation and the formula equation as well. Let us see the method for collecting hydrogen in the laboratory. Method for collecting hydrogen in the laboratory. Hydrogen gas is collected by downward displacement of water. Downward displacement of water. Displacement of water. Downward displacement of water, the reason is because hydrogen, the question is why? Why do we collect hydrogen by downward displacement of water? The answer is because hydrogen is insoluble in water. Hydrogen is insoluble in water. Insoluble in water. The word insoluble means hydrogen does not dissolve in water. So we collect hydrogen by downward displacement of water. Water will be displaced downward. Why? The reason is because hydrogen is insoluble in water. Hydrogen does not dissolve in water. That is the reason. So if you be given a question, explain why do we collect hydrogen by downward displacement of water, the answer is because hydrogen is insoluble in water. The last thing we are going to see today is the chemical test. Chemical test of hydrogen. What is the chemical test of hydrogen? Chemical test. How can you identify this gas is hydrogen? Chemical test. Hydrogen burns with a pop sound. Burns with pop sound. Pop sound. The sound is look like when you are preparing a popcorn. So the sound which is giving out is the same sound when you test hydrogen gas. That is the voice that you're going to be hearing. It is a pop. It burns with a pop sound. So this is a chemical test of hydrogen. This is how you can identify hydrogen from another gas. You are going to test if it can burn. It will burn with a pop sound. That is the chemical test of hydrogen. Now, write this as an exercise. Using a diagram, explain laboratory preparation of hydrogen. Laboratory preparation of hydrogen. Try to do it. You're going to answer this question by using the diagram. You're going to answer this question by using a diagram. Thanks very much for listening. Thanks for joining with me in chemistry session. I hope to meet with you next time. My name is Madam Jennifer Kaislege. Goodbye.
Let's study, be educated.